Right. Can you see the slides?
Yes, sir.
Today's class it is about power, fractional power. One kind of fractional power is it's about a to the power of 0.5, right?
Yes, sir.
Try to convert 0.5 into common fraction. It is decimal fraction, yes?
Yes, sir.
How
It's
to
1
convert?
by 2.
Yeah, 0.5 by 10, right?
Yes, sir.
Which means, sorry, yeah, 0.5 means 5 by 10.
Yes, sir.
When we convert the decimal fraction into common fraction, it is 5 by 10, right?
Yes, sir.
Yeah. Cancel 5 by 10?
It's 1 by 2, sir.
Yes, right. 1 by 2. 0.5 means a to the power of 1 by
1 by.
a power 0.5 means a power 1 by 2, right?
Yes, sir.
Now, a power 1 by 2 is nothing but square root of a to the power of 1. 2 is written here and 1 is written to that power, right?
Yes, sir.
Square root of a to the power of 1. Simply, it is written as root a. Root a is nothing but square root of a power 1.
Yes, sir.
Another name of root a is, another name of root a is a to the power of 1 by 2 or a to the power of 0.5, right?
Okay, sir.
Please tell some square roots. For
Like
example, the square root of
square root of 5, sir.
5.
I mean, 36, sir.
Yes, very good. The square root of 36 is equal to
6, sir.
very good. Tell few more examples.
Square root of 4, sir.
Yeah, is equal.
2, sir.
Very good.
And the square root of 8 is 4, sir.
No, square root of 8 is 4. Yeah, let us check whether it is correct or not. See, as you said, the square root of 36 is equal to 6, right?
Yes, sir.
Let us check whether it is correct or not. It is 6, right?
Yes, sir.
Take 6 and find its square. Means 6 times 6. What is 6 into 6?
36, sir.
Yes, that's why it is correct. But you said the square root of 8 equal 4. Let us check whether it is correct or not. To check whether it is correct or not, we need to take 4 square. What's the value of 4 square? It is 4 times 4.
Which is 16, sir.
But not 8. That's why root 8 is equal to 4 is wrong answer.
Okay, sir.
So, and moreover, 8 has no square root because 8 is not a perfect square.
Okay, sir.
It's very clear. 8 is not a perfect square.
Okay, sir.
It has another name, that is perfect square or square number.
Okay, sir.
Some call it perfect squares, some call it square number, right?
Okay, sir.
36 is a perfect square, 4 is a perfect square, but 8 is not a perfect square.
Okay,
That's why
sir.
there is no integer root for 8, since it is not a perfect square. Give few more examples for square roots.
Square root of 16, sir.
Yeah, right, correct only. Square root of
Which is
16 is equal to
4.
very good. Now
And
tell as many as possible, as many as you can.
okay, sir. Square root of 91. I mean 81.
Yeah, 81 is equal to,
9, sir.
yeah, keep telling.
And then the square root of 100 is 10.
Very good. Few more.
Then square root of 121 is 11, sir.
Very good. Few more.
And square root of 25 is 5, sir.
Very good.
The square root of 9 is 3.
Right.
And then square root of 49
Is equal to
7, sir.
right.
And square root of 64 is 8, sir.
Very good. Keep telling. Yeah. So many are there. Hundreds of the examples are there.
Yes, sir.
Yeah. I'm asking you tell square root of 144.
What, sir?
Square root of 144.
It's 12, sir.
Very good. The square root of 196.
13, sir.
Very good. The square root of 225.
It's 25, sir.
No.
I mean,
Not 25.
15, sir.
Very good. Yeah, right. Now, let's have a brief discussion on it. Once read this sentence.
A simple guide to square roots and their applications.
Yeah, heading is
understanding square roots.
very good. Now, just see, right? Read.
The square root of a square root of a number is the value that to be multiplied by itself, giving the original number.
Very good.
Example, 9 to the power of 9, square root of 9 equal to 3.
Square root of 9 is equal to 3.
Because 3 into 3 is 9.
Yeah. Give one more example. For example, as you said, the square root of 36 is equal to 6. Because
6 into 6 is 36.
very good. Say a few more sentences. Frame few more sentences like this.
Square root of 81.
Very good. Very good.
Equal to 9 because 9 into 9 is 81.
Very good. One more example.
Square root of 25 is 5 because 5 into 5 is 25.
5 into 5 is equal to 25. Perfect. One more example.
Square root of
similar sentence. Create a similar sentence like this.
Okay, sir.
Yeah, bullet. Square root of
49.
Yeah.
Equal to 7.
Perfect.
Because 7 to 7 is 49.
7 times 7 is equal to 49.
49.
Very good. Right. Now,
yes, sir.
Just read last sentence.
Simple root is called the radical sign.
Yeah, it is called radical sign or square root or radical sign, right?
Okay, sir.
They're called radicals. Fractional powers are called radicals.
Okay, sir.
Yeah. I forgot to prepare an image. Actually, I thought to prepare a image for this visual, but
yes,
it's not completed. In the next class, I will show you the visuals. That means images, right?
Okay, sir.
A square with side length. It is a square. Its side is 4. 1, 2, 3, 4. Right?
Okay, sir.
So this distance is 4 units. What is the area of this square?
16, sir.
Yeah, its length is 4 units. 1 unit, 2 unit, 3 unit, 4 unit, right?
Yes, sir.
Then what is its area?
It's 16, sir.
Yeah, just one count all the squares on the checks, all the checks, number of checks. 1, 2, 3. Sorry. One line is extra.
Yes, sir.
It's extra line. Oh, sorry. Let me try it again.
Okay, sir.
See, it is a square. Yeah. Length of the square, side of the square is 4 units,
Four.
right?
Yes, sir.
1, 2, 3, 4, right?
Yes, sir.
Each side is of length 4 units. Now
Yes, sir.
count number of checks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right?
Yes, sir.
Totally, how many inner squares are there?
16, sir.
16, because its side is 4 units.
Yes, sir.
So, formula to find the area of a square is side square.
Yes, sir.
Here side is 4, 4 square is equal to 16.
Okay, sir.
Yeah. Now tell what is the use of, what is the application of squares? What is the application of squares? Yeah, in finding area of a square, right?
Yes, sir.
What's the use of square? What's the use of learning squares? Because squares are used in finding area of a square, right?
Yes, sir.
If side of a square is given, we can find its area. Okay, by using the concept of squares.
Yes, sir.
For example, if the side of a square is 3 units, then what is its area?
9, sir.
Very good. Squares are used in finding the areas of squares. Of course, areas of circles, so many applications are there. We are taking one example. That example is squares are used to find the areas of a square. That means if side of a square is given, we can find its area by squaring it, by finding its square.
Yes,
Square
sir.
is 25. That's why it is the use of squares, right?
Yes, sir.
Now, it's about square roots. What is the use of square roots? For example, there is a square whose area is 9 square units. Then what
sir.
is its side? Square is 9 units. Then previously, we found area of a square when side is given.
Yes, sir.
But now, area is given. We are asked to find its side. Previously, we used the concept of square. By using concept of square, we found the area of a square, okay, when side is given, but it is reverse process. Here area is given, asked side. Do you have any idea?
It's 3, sir.
Yeah, 3, very good. How did you get that 3?
Because the square root of 9 is 3.
Right, excellent. So, sides of a square can be found by calculating square roots.
Okay, sir.
Area of squares can be found by finding squares.
Yes, sir.
Please tell how to find side of a square. By
doing the square root of the number.
Yes, perfect. How to find area of a square?
We just have to do the number and the squares.
Just finding its square, right?
Yes, sir.
Observe that both concepts are opposite.
Yes, sir.
Yeah, or in other words, reverse.
Yes, sir.
Reverse process or reverse opposite operations and reverse process, right?
Yes, sir.
Yeah. See, read this bullet points.
A square with a side length 4 has area is equal to 4 into 4 equal to 16. Sir.
Perfect. Next.
Therefore, 16 square is
root
of 16 is 4. Sir.
Perfect. Right. Yeah. Now, just it's very important concept. Just read that sentence.
perfect squares have integers square roots. Sir.
Those are called perfect squares.
Okay, sir.
These are the examples for perfect squares. As we said in the previous discussion, we failed to find the integer root of 8, right?
Yes, sir.
There is no integer. Do you know the difference between integer and non-integers?
Yes, sir.
What is your roll number?
What, sir?
Your roll number in class, in our class?
2, sir.
2. It is an integer, right?
Yes, sir.
Approximately tell the weight of your pen. Approximately, it may not be accurate. Tell one number. What may be the integer of this pen?
Of like 1 gram.
It can be 12.5 grams.
Yes, sir.
Let us suppose, right?
Yes, sir.
Is it integer or non-integer?
The non-integer.
Yes, very good. It is non-integer. Yeah. Give an example for non-integers.
Like 8.2, sir.
Yeah, 8.2 is another example for non-integer. This is 8.2 is an example for non-integer. You can tell the non-integers in common fractions also.
Yes, sir. Like
Tell one more example for non-integer.
Like 5 by 9.
Yeah, 5 by 9 is a non-integer, right?
Yes, sir.
Now give examples for integers.
Like 5.
Integers.
Oh, integers, sir. Like
5 is an integer.
Minus 2.
Integer. 9 is an integer, of course. Oh, yeah, go ahead.
And then minus 2.
Of course, minus 2 is an integer. As of now, at present, we are not dealing with, we are not discussing negatives. We will discuss negative numbers, negative integers later, right?
Okay, sir.
Yeah, for a clarity, let us focus on positive integers only.
Okay, sir.
Yeah, tell.
11.
11.
13.
13.
And then 15.
Very good. Go ahead.
And then 16.
And one thing I suggest all my students to have patience in learning mathematics. Patience is the main factor in learning mathematics, right?
Okay, sir.
Don't be impatient. When I ask multiple questions and repeated questions, right? It is intention of asking repeated questions is to induce patience in you. Got it?
Okay. Okay,
Yeah.
sir.
Yeah. Give few more examples.
19.
19.
36.
36. Very good. One more example.
Then 14.
Yeah.
And then 6.
Yeah. What do you call them?
Integers, sir.
Integers, right?
Yes, sir.
Now let us find an integer whose square is 8.
Okay, sir.
Try to find an integer. Try to tell an integer whose square is equal to 8.
None of them, sir.
None of them. Very good. You are right. Perfect. You are understanding perfectly. Is there any integer? Is there any integer whose square is equal to 8?
No, sir.
No. That's why 8 is not perfect square.
Okay, sir.
8 is not a perfect square. I'm asking you, do you think that 36 is a perfect square or not perfect square?
It is a perfect square, sir.
How can you say that? What's the reason in saying 36 is a perfect square?
Because 6 into 6 is 36.
Yeah, of course. There is an integer whose square is equal to 36.
Yes, sir.
That's why it is called perfect square.
Yes, sir.
When I ask you what's the square root of 36, your answer must be 6.
Okay, sir.
If I ask you the reason, you will say because 6 into 6 is equal to 36. That's why root 36 is equal to 6.
Yes, sir.
Have you found the difference between two questions? One question is, I'm asking, do you think that 36 is a perfect square or not? That's the question number 1.
Okay, sir.
Second question is, what's the value of the square root of 36? What's the difference between these two questions? First question is, it's about justify whether it is perfect square or not.
Okay, sir.
Second question is about its square root.
It's the same, sir.
Yeah, right. There is slight difference is there in those two questions, right?
Because the first question doesn't have a square root.
Yeah, right. Yeah, I'm asking you two questions. Is 49 is perfect square?
Yes, sir.
Yeah, that's the question number one. Next question. What's the value of root 49?
7, sir.
Yeah, let me repeat the two questions again. First question. Is 49 is a perfect square?
Yes, sir.
Yes. What's the reason? How can you say that 49 is a perfect square?
Because 7 into 7 is
No, no,
49.
no. Your answer must be like this. There is an integer exists, or there is an integer whose square is 49.
Okay, sir.
That's it. Okay.
Okay, sir.
What is your answer for second question?
It's 7, sir.
Yeah. What is the reason in saying 7? Because
Because there is an integer.
no. Because 7 times 7 is equal to 49.
Okay, sir.
That's why the square root of 49 is equal to 7, right?
Okay, sir.
Yeah. Let me repeat similar questions. Yeah. Do you think that 100 is a perfect square?
Yes, sir.
How can you say?
Because there is an integer.
Very good. Very good. Perfect. Right. You're on the right track. Yeah. There is an integer whose square is equal to.
Square is equal to 100, sir.
That's it. That's it. Next question is, what's the value of root 100?
It's 10,
Yeah.
sir.
How can you say?
Because 10 into 10 is 100.
Because very good. Have you found the slight difference between these type of questions?
Yes, sir.
Very good. Perfect. Next. Yeah. These are examples for perfect squares, right?
Yes, sir.
See, let me repeat that point again. Since there is an integer whose square is equal to 64.
Okay, sir.
That's why 64 is called perfect square.
Yes, sir.
8 into 8 is equal to 64. That's why root 64 is equal to 8.
Okay, sir.
Yeah, there is a slight difference between these two statements.
Yes, sir.
Yeah, let me repeat again. For example, there is an integer whose square is 81.
Okay,
There
sir.
is an integer whose square is equal to 81.
Okay, sir.
That's why 81 is a perfect square.
Okay, sir.
81 is a perfect square. 9 into 9 is equal to 81.
Okay, sir.
Therefore, the square root of 81 is equal to 9, right?
Yes, sir.
First box is one statement, second box is another statement.
Okay, sir.
Yeah, you must be aware of the difference between these two concepts, right?
Yes, sir.
These are examples for perfect square. On this slide, there are some examples for perfect square. What are the examples of perfect square showing in this slide?
Square root of 1 equal to.
I'm asking, yeah, understand my question clearly. On this slide, there are some perfect squares.
Okay, sir.
Tell them what are the perfect squares showing on the slide.
It's
One
square root,
is a perfect square. Very good.
and then square root of 4 is 2, sir.
Just say, yeah, see, one is a perfect square. That's it. Four
Okay,
is
sir.
a perfect square, like that.
And 4 is also a perfect square.
Very good. Go ahead. Keep telling.
And the 9 is a perfect square.
Very good. Perfect. Next up.
And 16 is a perfect square.
Yes.
And 25 is a perfect square. sir.
That's it. That's it. Now I am asking you, how many perfect squares are shown in this slide?
5, sir.
Yes, very good. What are they? One.
Square root 1,
One is a
4,
perfect square. 4.
9,
Very good.
16,
Very good.
and 25, sir.
Yeah, these 5 perfect squares are shown in this slide, right?
Yes, sir.
How many perfect squares are there in your opinion? In your idea? Do you have any idea for the number of total perfect squares? For the total number of perfect squares?
No, sir.
Because no one can tell all the perfect squares, and
Yes.
no one can tell how many perfect squares exist, right?
Yes, sir.
Infinite perfect squares are there, right?
Yes, sir.
Yeah, to get more clarity, let's focus on imperfect squares or not perfect squares.
Okay, sir.
Can you give us some examples for not perfect squares or imperfect squares?
Like the square root of
No. Just say
8.
one number and tell it's
8.
not perfect square. That's it.
8's not a perfect square.
Yeah, very good. It's a old example. Tell fresh example.
And
New example.
7,
7 is not a perfect square. How can you say that 7 is not a perfect square?
because there is no integer.
Yeah.
whose
You are
value-
very good. You are on the right track. There is
Because
no integer
integer whose value is 7, sir.
whose square is 7.
Okay, sir.
There is no integer whose square is 7.
Yes, sir.
That's why 7.
That's why 7 is not a perfect square.
Very good. Very good. Excellent. Yeah. Next, give another example.
11, sir.
11. You think that 11 is not a perfect square, right?
Yes, sir.
What's the reason?
Because there is no integer
Yeah.
whose square is not 11, sir.
Excellent. Very good. You told well. Right. Now, see. Square roots of non-perfect squares, right?
Yes, sir.
Previously, it told few examples for non-perfect squares, right?
Yes, sir.
Continue telling examples for non-perfect squares.
13, sir.
14, right? 14 is not a perfect square, right?
Yes, sir.
Yeah. One more example.
15, sir.
Yeah, 15 is also not perfect square. One more example.
And then 17, sir.
Yes, perfect. Next.
And 21, sir.
Very good.
And 13.
Very good.
And 12, sir.
Yes. 3 plus 2, 5. 6. Yeah. Tell few more. 4 more.
And 27, sir.
Very good.
And then 28.
Right.
And then 24, sir.
Right. 3 plus 2, 5, 6. Yeah. One more.
And then 23, sir.
Very good. Right. Now, write the sentences showing on the slide.
Not all numbers have integer square roots, sir.
Perfect. Have you understood the meaning of this first bullet point?
Yes, sir.
Yeah. 16 has square root. 25 has square root, right?
Yes, sir.
There are some integers between 16 and 25. Okay.
Yes.
Which has no integer square roots, right? Which
sir.
has for them no integers exist such that whose square is equal to that integers, right?
Yes, sir.
Yeah. In simple words, we can say there are few numbers between 16 and 25 which are not perfect squares.
Okay, sir.
Can you tell how many are there? I'm asking you a simple question. How many imperfect squares are there between 9 and 16? Do you know both 9 and 16 are perfect squares, right?
Yes, sir.
9 and square are perfect squares.
Yes, sir.
Tell how many imperfect squares exist between 9 and 16?
10, sir.
Yeah, count them.
6, sir.
Very good. What are they? 10, 11, 12,
11.
13, 14, 15. Yes, exactly. There are 6 integers which are not perfect squares.
Yes, sir.
Lying between?
9 and 16, sir.
Yeah, right. Yeah. Now read them. Have you understood the meaning of the first bullet point?
Yes, sir.
That is
That is
not all numbers have integer square roots.
Yes, sir.
Some numbers have integer square roots, right?
Yes, sir.
Yeah. Give example for first bullet point. First point says not all numbers have integer square roots, right?
Yes, sir.
Example for the first sentence.
Like this,
As you told previously, just now. You told 6 numbers between 9 and 16. Give one
like
example.
10, sir.
Yeah, 10, right? 11.
11.
Example 10 and 11, 12, 13, 14, 15.
Yes, sir.
They don't have integer square roots, right?
Yes, sir.
That's why those are called imperfect squares, right?
Yes, sir.
Right. Second example, if we try to find the square root of a 2, do we think that square is a perfect square or imperfect square?
It's an imperfect square, sir.
Imperfect square. Perfect. Very good. You told correctly. See, for example, 49 is a perfect square or imperfect square?
The perfect square, sir.
Okay. We can find an integer. We can search for an integer whose square is equal to 49.
Yes, sir.
In that search, let us use trial and error method. Of
Okay.
course, just for a while, just forget you know the answer.
Okay, sir.
You are thinking freshly.
Okay, sir.
In the process of finding the square root of 49, what's the one process is taking one number. For example, we are taking 5.
Okay, sir.
We are checking whether 5 is its answer or not.
Yes, sir.
For that, we need to find the value of 5 square, which means 5 into 5, right?
Yes, sir.
It is 25.
Yes,
So
sir.
5 is its answer or not?
No, sir.
Then we try another number. Tell another number. For example, if we take 8,
Okay, sir.
8 into 8 is equal to 64.
65.
Is it equal to 49 or not?
No, sir. It's not
No.
14.
Neither 5 is correct nor 8 is correct, right?
Yes, sir.
Then what do we do? Take another number.
6, sir.
6, right? 6 into 6 is equal to?
36, sir.
Is it equal to 49?
No, sir.
No. That's why 6 is also not correct. In that search, in that process, we try another number.
Okay, sir.
What is that number?
7, sir.
Yeah, 7 into 7 is equal to?
14.
We got exactly 49.
Yes, sir.
That's why root 49 is equal to 7,
7,
right?
sir.
At last, we found the value of square root of 49, right?
Okay, sir.
Now, let us take another example.
Okay, sir.
Yeah, in the process of finding the square root of 2, right?
Okay, sir.
Let's forget the fact that 2 is not a perfect square.
Okay, sir.
Let's forget the fact that 2 is not a perfect square, right?
Okay, sir.
In the previous, like in the previous process, let's find the value of root 2, right?
Yes, sir.
For example, we are trying 3. 3 times 3 is equal to 9.
Yes, sir.
Is it a bigger number or smaller number to 2?
It's too big, sir.
Yeah, that's why 3 is not correct, right?
Yes, sir.
Let's take 2. 2 times 2 is equal to?
4, sir.
It's also big.
Yes, sir.
Let us reduce one more number. 1 times 1 is equal to?
1, sir.
1. Is it big or small?
It's too small, sir.
It's too small. So the answer must be in 1 and 2, right?
Yes, sir.
In the previous example, we tried 6 and we tried 8.
Yes, sir.
For 6, we got smaller number.
Yes, sir.
For 8, we got bigger number. Got it? In the
Got it,
process,
sir.
in the process of finding the square root of 69, right?
Yes, sir.
The process of finding the square root of 49. For 6, we got smaller number, and for 8, we got bigger number.
Yes, sir.
Then what did we do? We tried to find a number between 6 and 8.
Yes, sir. Because
That is
7.
That is 7. So here also, one is small, one gives smaller number and 2 gives bigger number, right?
Yes, sir.
The process of finding square root of 2, right?
Yes, sir.
We need to find a number between 1 and 2.
Okay, sir.
But unlike in the example of 6 and 8, there is an integer exists between 6 and 8.
Okay, sir.
Are you getting me?
Yes, sir.
In this example, there is an integer exists between 6 and 8.
Okay, sir.
That is 7.
Yes, sir.
But in this example, do you think that is there any integer lying between 1 and 2?
It's in decimal, sir.
Is there any integer lying between 1 and 2?
No, sir.
No. That's why it has no integer root, integer square root, right?
Yes, sir.
That's why after failing to find an integer square root,
Yes, sir.
after knowing that there is no integer whose square is equal to, getting me?
Yes, sir.
As we know, there is no integer whose square is equal to.
Yes, sir.
In that process, let us take one non-integer between 1 and 2, right?
Okay, sir.
Tell one non-integer, for example, 1.1, right?
Okay,
So
sir.
answer of the square root is must be greater than 2 and less than 2.
Yes, sir.
The answer must be in 1 and 2, between somewhere in between 1 and 2, right?
Yes, sir.
For that, we take 1.1. Square root of
Yes.
1.1 is 1.1 times 1.1 is 1.21, right?
Yes, sir.
Is it equal to?
No, sir.
No. That's why we take 1.3. 1.3 times 1.3 is equal to 1.69. Is it equal to?
No, sir.
If we take 1.5, if we take 1.5, 1.5 times 1.5 is 2.25, right?
Yes, sir.
Is it bigger than 2 or smaller than 2?
It's bigger than 2, sir.
1.5 gave bigger number, 1.3 gave smaller number, right?
Yes, sir.
2 is more than 1.69 and less than 2.25, right?
Yes, sir.
So let us choose a number between 1.3 and 1.5. Of course, it is not an integer, right?
Yes, sir.
What number exists between 1.3 and 1.5?
1.4, sir.
Yeah, 1.4. If we take 1.4 times 1.4, it gives 1.96, right?
Yes, sir.
Of course, it may not be equal to 2,
Yes, sir.
but it is approximately equal to 2, right?
Yes, sir.
1.96 is just 0.04 less than 2, right?
Yes, sir.
So if I ask you to find the square root of 2, we can say it's approximately 1.4, right?
Yes, sir.
If we go on this process, we will get 1.414, so on, so on. I will show one number. You will be surprised. Yeah, scientists are very interesting in finding the square root of 2. Have you seen the screen?
Oh my God.
In the process, as we started the process, we started a process to find the square root of 2, right?
Yes, sir.
Yeah. We found one digit, 1.4 only, right?
Yes, sir.
Yeah, see, scientists are how curious they are in finding the square root of 2. Just read this.
The
The
square
square,
root.
the square root of 2 is equal, right?
Yes, sir.
Its answer is we found up to this only, right?
Yes, sir.
We took that much of time to find just one digit after point, right?
Yes, sir.
See how many digits are found. These are all, this is square root of 2 only. Yeah, it
Yes.
starts from 1 point.
And it keeps on going.
Yeah, see, just let us start. Just for understanding, I ask you to read just 10 or 15 numbers. See, read like this. The square root of 2 is equal to, yeah, read.
The square root of 2 is equal to
Yes.
1.41
Very good. Very good. Thanks for your patience. Right. Let
1
Yeah, right. Let us take few points.
Okay, sir.
Right. Yeah. And one thing is very clear here. If we find 1.1, 1.4 square, we don't get 2. But this value is approaching to, right?
Yes, sir.
There is much gap between 1.96 and 2, right?
Yes, sir.
Please tell how much gap is there between 1.96 and 2?
It's
That gap is
0.4.
0.4, right?
Yes, sir.
To reduce this gap, uh, 1.41, right?
Yes, sir.
If you take 1.41 and finding its square, we will get 1, 8, 1 plus 16, 17, 18, and 9, and 1. Its value, if we take 1.41, yeah, its square is equal to 1.9881, right?
Yes, sir.
This number is more nearer than 1.6, 1.9622, right?
Yes, sir.
What's the gap between these two numbers? It's 0.02 only, right?
Yes, sir.
No. Yeah. Just if we add 0.02, it becomes, right. Its gap is 0.02, right?
Yes, sir.
What is the specialty of 1.41? It reduces the gap.
Yes, sir.
It reduces the gap when compared to 1.4, right?
Yes, sir.
If we take one more digit, that implies, at first we take 1.4, right?
Yes, sir.
The gap is 0.04, right?
Yes, sir.
If you take one more digit, the gap is 0.02 only, right?
Yes, sir.
If you take one more digit, the gap will be 0.01, right? Something like this, right?
Okay, sir.
If we use few more numbers, the gap will be 0.0000, very slight gap is there.
Okay, sir.
At last, the purpose of showing all these digits is to make you understand scientists or mathematicians are how curious they are in reducing the gap between 2 and that square number, that square value, right?
Yes, sir.
Yeah. For a recorded information, there are records also there in telling the square root of 2.
Okay, sir.
There are some square roots, records are also there in telling, reciting. In other words, it is called reciting the square root of 2. I will show. Yeah. Just see.
With this AI tool, you can turn your story into a beautifully illustrated
Yeah,
children's book.
mom told that you had a record in Telugu Book of Records.
Yes, sir.
Yeah, that's why I show you this record.
I'm studying in grade 7 in VP Siddhartha Public School, Vijayawada. I'm participating in Math Genius World Records and Awards, and now I'm going to decide the first 600 decimal places of root 2 value.
Yeah, root 2 value.
1.41422135.
Just wait. Do you remember? Tell few digits as you can. How many digits you can tell? 1 point, just 3 or 4.
Okay, sir.
Yeah, tell.
1.41421356237330950801.
Enough. Yeah, in few seconds, try in 10 seconds, try to remember as many as you can.
Okay, sir.
Just in few seconds, right? Try.
Yes, sir.
Yeah. Got it? How many you can?
I did like 6 or 7, sir.
Yes, super, very good. Tell them.
Wait a minute, sir. Um, 1 point.
Yes. Yeah, you have to start with the square root of 2 is equal to.
Okay, sir. The
Tell.
square root of 2 is equal to
Yes.
1.41 1.414
Yeah.
21
Yes.
3
Yeah.
5
Yeah. 6. Good, good. Excellent. Right. See, see,
2135.
just listen.
1.414213. The first 600 decimal places of. I'm going to decide the first 600 decimal places of root 2 value. 1.414213563 04880
Yeah. Do you understand the depth in square roots?
Yes, sir.
Yeah, I will teach you some tricks are there in remembering them.
Okay, sir.
Right, right. There are some tricks which are called peg system and link system. Yeah, I will teach you later the peg system and link system, so that you will remember within few. I can make you to remember uh, more than 30 digits within few minutes. I
Okay,
will tell
sir.
that secret later. Okay.
Okay,
Right.
sir.
Let's come to that point. Yeah, have you understand between the perfect squares and imperfect squares?
Yes, sir.
Yeah, and the fact is, um, if you write as many digits as you can, 1,000, 1 lakh, 1 crore, even then you can't get the exact two.
Yes, sir.
But you can reduce the gap between two and that square number, right?
Yes, sir.
Yeah, right. Read this. Yeah, this it will be learned later. Right. Yeah. Answer for first question.
Okay, sir. Square root of 64 is 8, sir.
Right. It's 8, right? Okay.
And then the square root of 121 is 11, sir.
Very good.
And then the side of a square with area of 81 centimeters square is 9, sir.
Very good.
Is the square root of 20 a whole number?
That means, in other words, same question can be asked as, do you think that 20 is a perfect square?
Yes,
Same
sir. It is.
question can be
Not-
asked in another version, right? Yes or no?
No, sir.
Our answer is no, right?
Yes, sir.
Right. Yeah, just read.
Square root reverses squaring a number.
Yeah, as we discussed earlier, square root and square are both reverse processes, right?
Yes, sir.
Both are reverse processes, are opposite operations.
Okay, sir.
Yeah, right. Second point.
Perfect squares have integer roots.
Very good. Others in the sense?
Means it
Others
other
means?
not
Others,
all integers have
yeah, others means? What do you think?
imperfect squares, sir.
What the word others refer to? Yeah, you are right. Very good. Equal perfect, correctly. Other refers to imperfect squares.
Yes, sir.
Excellent. Next.
Square roots have many practical uses.
Yeah, many practical use, especially in geometry, in finding area of square, area of circle, area of triangle, and area of hexagon. So many applications are there. All those will be learned later, right?
Okay, sir.
Right. Now, I will tell some tricks slowly.
Okay, sir.
Find the square roots. At present, as of now, up to which number you can find its square root for perfect squares?
Until
Until
140.
144 only.
Yes, sir.
Let's go beyond that. The square root of 144 is equal to 12, right?
Yes, sir.
The square root of 625.
Um,
Is it beyond our capacity?
yes, sir.
Yeah, okay. We need a number which is beyond our capacity at present, as of now.
Okay, sir.
Let us take this number, right? Yeah.
Okay, sir.
Let us try to find its value, right?
Okay, sir.
In that process, how do we do? What do we do? Let's take a number,
Okay, sir.
right?
16, sir.
16. 16 times 16 is equal to 56. The answer must be more than 16 or less than 16.
More than 16, sir.
Yeah, right. Tell another number. I will tell its square to save time.
21, sir.
21. 21 times 21 is equal to 441.
It's bigger. Let me say it's
Yeah,
bigger than.
no. It's also smaller. It is 625. It is 441.
Yes, sir.
Right.
So 24, sir.
24 square is equal to 24 times 24 is equal to 576.
26, sir.
26 square is equal to 26 times 26. It is equal to 676.
That means it's 25, sir.
25 square. 25 square is equal to 25 times 25. It is 625. So answer is
25, sir.
25. Perfect. Now I am asking another question. That is 729. Let us try to find the value of root of 729.
28, sir.
28 square, 784.
That means it's 26, sir.
26 square. Yeah, we have here 26 square.
Oh, that means it's 27, sir.
27 square, 729.
Got it, sir.
So answer is 7 to 10. Let us write another number. All this is to make you to get in-depth knowledge in square roots, right?
Yes, sir.
But I will tell you a super shortcut to find the square root of any number until 10,000 or 1 lakh.
Okay, sir.
Sure. I will make you to tell the square root of any number till 1 lakh. Definitely.
Okay, sir.
But we don't ignore the general process.
Okay, sir.
We don't ignore the manual process. We don't ignore the normal process, right? First,
Okay,
we
sir.
have to learn the normal process. After that, we will learn the shortcuts, super shortcuts,
Okay.
right?
Okay, sir.
We must get grip in normal method also.
Okay, sir.
After learning normal method, I will teach you the super shortcut method to find its square roots, right?
Okay, sir.
Now, I am giving another example that is equal to 961. Tell one number, I will tell its square.
35, sir.
Very good. 35 square is equal to 1225.
Is it 29, sir?
29 square, 841.
Um, 31, sir.
31 square is equal to 961.
Okay, sir.
Got it?
Got it, sir.
Answer?
It's 31, sir.
Very good. Now one more example. The square root of 1089.
Is it
Square root
30?
of 1089.
Is it 34, sir?
34 square 1156.
Is it 33, sir?
33 square 1089. So answer is
33, sir.
yeah. Do you want to know to tell the squares of any number like me?
Yes, sir.
Yeah, surely I will make you. You tell any number, I will tell its square spontaneously, instantly. And I'm sure that you will be able to tell like me.
Okay, sir.
Yeah, I'm giving one more example. I'm giving bigger number, that is 2401.
39, sir.
39 square 1521.
What about 42, sir?
42 square 1764.
What about 44, sir?
44 square 1936.
46, sir?
46 square 2116.
That means it's 45, sir.
45 square 2025.
Hmm. What about 49, sir?
49 square 2401. Answer is
49, sir.
yeah. Now I'm giving you a task. That is, I am asking about 1849. You may ask as many questions as possible, but
Yes, sir.
I am giving only 4 chances. In 4 chances, you have to tell its answer.
Okay, sir.
Only 4 questions. You can ask me only 4 questions.
Okay, sir.
Yeah, try.
What about 34, sir?
34 square 1156.
39, sir?
39 square 1521. Of course, not 4, 6 chances. I am giving 6 chances.
Okay, sir. 45, sir?
45 square
Yes, sir.
2025.
43, sir?
43 square correct only. 1849. How many chances you took?
4, sir.
Yeah, exactly. You took only 4 chances, right?
Yes, sir.
Yeah. As I promised you to make you to tell the square roots for any number till 1 lakh.
Yes, sir.
Now I am giving first step, right?
Yes, sir.
Do you want to learn?
Yes, sir.
Yeah. In first case, in first step, let us try to find the square root of a perfect square whose ending with 5.
Okay, sir.
For example, 3025, right?
Okay, sir.
It's very simple. You can answer this question within a second. I'm sure. Of course, within 5 seconds. Within 5 seconds, you can tell the answer of a number, square root of a number like this. Yeah, I'm telling the trick only, right?
Yes, sir.
First, tell me the value of 1 square,
It's 1, sir.
2 square,
It's 4, sir.
3 square,
It's 9, sir.
4 square,
16, sir.
5 square,
25, sir.
6 square,
36, sir.
7 square,
49, sir.
8 square,
64, sir.
9 square.
81, sir.
Got it?
Got it, sir.
Leave the last 2 digit numbers.
Okay, sir.
What's the remaining number?
30, sir.
30. What is the nearest number for 30? but that number must be less than, not greater than 30. Not greater than 30. Not greater than 30. What is the nearest number?
25, sir.
Very good. Its square root is
25.
square root.
It's
Now,
5, sir.
Yeah. 5 square is 25, right?
Yes, sir.
So we have to take the first digit 5.
Okay, sir.
Last digit is same as this. That's it. Shall we check whether it is correct or not? How to check whether it is correct or not? We need to multiply 55 by 55. 25, 27, 25, 27, 5, 12, 0, 30. Correct or not?
Correct, sir.
Now try another number. What is the value of the square root of 1225?
Okay, sir.
Not greater than 12. Nearest number, not greater than 12. In this list, 1, 4, 9, 16, 25, 16,
Okay, sir.
49, 16, 4, 81.
Okay, sir. Is it 95, sir?
Yeah, first of all, leave the last 2 digits and
Okay,
it is
sir.
12. What's the name?
It's 9, sir.
Yeah, 9 means?
3, sir.
Yeah, 3. Last digit is same as this.
So it's 5.
Answer is?
35, sir.
Check whether 35 is correct answer or not.
It's correct, sir.
Very good. Now, another number, 4225. 4225.
Yes, sir. Is it 65, sir?
Yes. Check whether it is correct or not to get satisfaction, to boost confidence.
It's correct, sir.
Very good. I am giving another number. 2025. This year, this year,
Okay, sir.
2025.
Is it 45, sir?
Perfect. Excellent. Check it.
It's correct, sir.
Very good. One more example. The square root of 5625.
75, sir.
Perfect. Correct. We don't have to check it. Yes, it's correct only.
Yes.
Now, 7225, 7225.
85, sir.
Perfect. 85 correct only. The square root of 9025.
Is it 95, sir?
Perfect. Check just to boost your confidence.
It's correct, sir.
Very good. Got confidence?
Yes, sir.
Yeah, in the first phase, I taught you to find the square roots of numbers ending with 5, right?
Yes, sir.
In the next class, we will be learned for other for any numbers ending with any number, right?
Okay, sir.
In the first phase, you have learned to find the square root of a number ending with 5, right?
Yes, sir.
The same way, you can tell the square root of any number ending with any number.
Okay, sir.
Right. And meanwhile, I suggest you, laptop is available to you, a laptop or tab or anything.
Yes, sir.
Yeah, I suggest you to practice on it. It is a special software. It is free. See, this website was introduced to us in Germany. In
Okay, sir.
last chapter, I attended Germany for mathematical conference.
Okay,
Yeah,
sir.
it is free website. My friend created this website. This
Okay,
is
sir.
very useful for you to get mastery in calculations, right?
Okay, sir.
See how to open it, mentalcalculations.org, right?
Yes, sir.
No problem. I will send you the link only. In
Yes,
this
sir.
GMCA simulators, I will
Okay.
tell you how to practice. Take multi operations.
Okay, sir.
Yeah. Yeah. What's the value? 5/3. Okay, let's skip it. Can you tell its value?
Is it division, sir?
Yeah, division. Yeah.
Okay.
Say any number, whether it's correct or not. It's just for practice only. Say some number. Of course, it may not be. It may be correct. It may not be correct. No problem.
Is it 1.5, sir?
1.2. Of course, it's wrong. Just for practice only. We are learning. Next question.
11, sir.
Yeah. Submit. Next question.
0, sir.
Yes. Next question.
2, sir.
Yeah. Next question.
Is it
Something.
1.6, sir?
1. Yeah, 6 only. 1.6 something like that. Result C. Correct answers. 3. Average
Okay,
time per question 12.56 seconds, right?
yes, sir.
Yeah, if you use this website, it's free website. We need
Okay,
not
sir.
pay anything for it, right?
Okay, sir.
In this, square roots are also there,
Okay, sir.
but yeah, square roots. But these are different. Questions are like this. What
Okay,
is the
sir.
square root of 25189, right?
Okay, sir.
I haven't taught you how I haven't taught you how to find the square roots not ending with 5, right?
Yes, sir.
So far, we have discussed only for the square roots ending with 5 only, right?
Yes, sir.
It's not ending with 5. It ends with 9 only. Okay, right?
Okay, sir.
After teaching the remaining phase also, you will be able to find the square root of this number also without
Okay, sir.
using pen or paper, right?
Okay, sir.
And meanwhile, I suggest you to take multi operations. It's for
Okay, sir.
practice. Multi operations.
Okay, sir.
Yeah, and questions are like this. Start quiz 8/6 like that. Okay, of course you can leave divisions. Okay. Tell number, approximate number. 1 point.
1.7, sir.
1.07, 20. 1.3 like that.
Okay, sir.
Next, its value.
10, sir.
Yeah. Next,
1, sir.
very good. Next,
63, sir.
yeah, right. Next,
7, sir.
right. Next, that's it. Got it? Which answer is wrong in your opinion? Out of 5
The
questions.
division one, sir, the
4
beginning.
Yeah, right. We have to increase the digits, right?
Yes, sir.
Slowly, you will be learning all international techniques in calculations ones. Okay, right? Okay. Thank you, Anvita. We'll meet you tomorrow.
Bye, sir.
Bye.